We are starting section 3.3 today. Today we'll be talking about inequalities. When we finish section 3.3, it will be about absolute values. So we are going to solve systems of linear inequalities. Not much of what we talk about today will be anything brand new. It's really just a fusion of multiple things that we've done so far. Systems and linear inequalities. In order to review or warm up, we are going to graph this one single inequality. Now for a refresher, we had to graph a boundary line, decide if it was going to be solid or dashed. We had to test a point, and then we had to shade on one side of our line. That's what kind of problem we're doing right now. So let's start with graphing. Can anyone help me out with graphing this line? Jacob.
-1.
What about it?
Go to -1.
On the
x-axis, y.
On the y-axis. We go to -1 on the y-axis. If you need to label your axes, go ahead. We put a point there. That's our y-intercept, -1. Alright, then we are going to use our slope. Jacob, what's our slope?
That would be 4/1.
4/1. So we are going to move up 4 and over 1 and put another point. Up 4/1, put a point. And we can keep on putting more and more points. Going up 4 to the right 1, up 4 to the right 1, or down 4 to the left 1. To the left 1. Okay, right. We can make this line. Somebody new, tell me if the line that I create should be solid or dashed. Charles. Dashed. If there is not an equal to bar on our inequality symbol, we are going to use a dashed line. So my line won't be as pretty as yours. You should still use a straight edge when doing this so that you get a nice line. Yeah, mine's not straight at all. All right, we have our boundary line. We are, I don't know, about a third of the way done. We have to pick a test point. Okay, a lot of the time we like to use 0, 0. We still can, as long as we can identify if we're going to be shading above or below the line. Okay, so if we're testing 0, 0, that's right there. Okay, so that's just slightly to the left of my line. Alright, we test the point 0, 0. That means I'm plugging 0 in for the y. And I'm plugging 0 in for the x. What is 4 times 0? What is 0 minus 1? Is 0 less than -1? Yeah. Only one person knows the answer to that. Is 0 less than -1? No, everyone should be able to answer that question. So I don't shade where that point is. If this does not work, we do not shade where that is. We go to the other side of the line.
I thought this was in the last year.
So we are going to shade this whole side. Jacob, did you have a question?
Why are we doing this again?
We are reviewing this because we are going to need to use this skill today. Alright, our notes for today. You can also solve a system of linear inequalities by completing the following steps. Graph the first boundary line. Shade for the first inequality. Graph the second boundary line. Shade for the second inequality. Determine where the shading overlaps. And that is where the solutions for the system lie. So we basically do two problems on the same graph and then figure out where they overlap. Kind of like when we graphed compound inequalities on a number line with the word and, we wanted their overlap. It's the same idea. We want to know where our shading is going to overlap for both lines. All right, our first example, we're not going to graph just yet. We're just going to decide if negative 3, 3 is a solution to the system of inequalities they gave us. So we're just checking to see if this works. For it to be a solution, it has to work in both systems. So let's check the first system. What am I plugging in for y?
3.
I'm plugging in a 3. So we would have 3 minus 2 times, what's going in for x? Negative 3 is less than or equal to 1. Now we have to decide if this is true. So we multiply first. Negative 2 times negative 3 turns it to a positive. 2 times 3 is 6. Okay. And what is 3 plus 6? 9. So this says 9 is less than or equal to 1.
False.
False. No, it does not work. So do I even need to bother checking the other one?
No.
No. If you want to, you can, but there's really no reason to. So is it a solution? No. Okay, if you want to check the other one, go right ahead. It might work in that one, it might not, but we don't really care. It didn't work in the first one, so it is not a solution to the system. Now we get to the fun stuff. We are going to solve the system. Y is less than or equal to 2x plus 2. Y is less than negative x plus 1. All right, we need to graph the first boundary line. So we're going to first graph y is less than or equal to 2x plus 2. Who can raise their hand and help me with the graphing that? Emily. Put a point at 2 on the y-axis. Okay, our slope is 2 over 1, so we go up 2 to the right 1, and we can keep on putting more and more points to get a good idea of that line. Emily, is that line going to be solid or dashed? Solid. We've got the equal to bar. So that means it will be solid. Ooh. Wow. Then we have to go graph our second boundary line. Someone new volunteer to help me with our second boundary line. Someone I haven't heard from yet today. Sadia. Okay, 1 on the y-axis. And then? Down 1 to the right one. Our slope is negative 1, so that means down 1, right 1, down 1, right 1, or we could go up 1, left 1. Now when we were graphing systems of equations, we wanted them to cross nicely at a point. Do these lines do that? No, and that's okay. It's fine. We don't need to worry about it. All right, is this line going to be solid or dashed? Dashed. All right, I just realized I went slightly out of order with the steps because this is how I'm used to doing them. Technically, we should have done our shading for the first line before we graphed the second one. It's okay. It's not going to make a huge difference. So we're just going to keep on going. Do we have questions about graphing our boundary lines? We don't care about the point of intersection this time. When we do equations, when they both have equal signs, we care very much about the point of intersection. On these ones, we don't really care about identifying that point. It's not part of our steps. What we do care about is where we end up shading for both of these. Okay, so let's go back to the top one. We need to pick a test point for this solid line that we made first. What do you want your test point to be? 0, comma, 0. Okay. So if we test 0, 0, what am I plugging in for y? 0 is less than or equal to 2 times 0 plus 2. What's 2 times 0? 0. 0 plus 2. So we end up with 0 is less than or equal to 2. Is that true or false? Is 0 less than 2? Yes, so that works. So for this first line, the solid line that we made, we are going to shade where 0, 0 is. And that is on this side of the line. So I'm ignoring that dashed line when I shade. It acts like it's not even there. Now I would not shade in so dark that you can't see anything through it, because we're not done with the problem. So just a little light shading so that you knew which side you were working with. Then we have to test a point for the other inequality. So for this dashed line, we've got to pick a test point. We again can use 0, 0. This line doesn't go through it either. So if I again test 0, 0. 0 in for y. Zero is less than negative 0 plus 1. What's negative 0? It's just 0. So we end up with 0 is less than 1. 0 plus 1 is 1. Does that make sense? Is 0 less than 1? Yes. So we again shade the side that has that point. So that means we are looking at the dotted line. We're shading kind of below it where 0, 0 is. And we this time are ignoring the solid line. So we're shading everything down here. Again, I wouldn't shade so much that you can't see anything through what you're shading, because we still are not done with our problem. We got one last step, and that's the easiest one of all, as long as we've done the rest of them right. That last step, the fifth step, said determine where the shaded regions do what? Overlap. Where is that happening? Kind of down at the bottom of the x-axis, right? This somewhat triangular shape down at the bottom. Do we see where my shades overlap? I used different colors. It's hard to see on the board, but I also went in different directions. See where the side-to-side shading overlaps the up and down shading? That is the region of intersection. So that is where our final answer is. So if you're doing this on your paper and you're kind of lightly shading on both sides, like I did on the board, that's fine, as long as then you go back over and you really dark shade in your final answer. Your graphs are your answer to these. So this is how I know that you knew what the final answer was. Just go back over it, shade it in a little darker. The other option, if you don't want to waste lead on it, is to waste your eraser on it. You can go back through and erase the shading that you don't want to use. Okay, you can go back through and erase the shading that did not overlap. Either way, doesn't matter to me as long as I can tell what your final answer is. All right, we will try to do this one where we graph, then shade, then graph, then shade, and you can kind of decide which way you like better. The issue with graphing both lines and then shading is some students get confused about which line goes with which shading. And these ones are both going to be what kind of line? Solid or dashed? Solid. So might be a little harder to tell them apart for some people. Maybe not. Maybe you do just fine telling your lines apart. Let's graph the first one. First one is a special type of line. Does anyone know what's special about it? Jacob?
Parallel.
Not exactly.
It's straight.
It's a straight line. We would technically call most of our lines straight lines, but you need to be a little more specific. Straight in what sense?
Like on the x-axis or the y-axis.
Which one?
Well, this one would be the y-axis.
The y-axis. It's a y line. So would it be vertical or horizontal? Horizontal. So we are going to put a point at 3 on the y-axis and make a horizontal line that goes through it. We've already talked about how it needs to be a solid line. Alright, so we have a solid line. Y is less than or equal to 3. Then we have to pick a test point. 0. 0 is an easy one to plug in. We only have a y to plug into, so we don't even worry about the x. Is 0 less than or equal to 3? Yes. So are we going to shade above or below our line? Below. Remember, when you do this initial shading, I wouldn't do it too dark. We are just seeing what we would shade for that first line, and then we'll go back through and do our second line. All right. On the second line, we've got y is less than or equal to 1/2 x plus 1. On this one, where am I starting my graph? Somebody raise their hand and help me with this one. O-axis.
1 on the y-axis.
I'm going to start at 1 on the y-axis. 1 on the y-axis. So this is part of why I wouldn't shade too dark, because now we're going to be writing through what we shaded over. Alexis, what's our slope?
1/2, up 1, right 2.
Good. Up 1, right 2. Up 1, right 2. And we've already talked about this. Our line is going to be solid or dotted? Solid. So, however many points you need to get a good idea of what this should look like. Now we have to decide where we are going to shade. What point do we want to test? 0, 0 is always the easiest one as long as our graph doesn't go through it. We plug a 0 in for y, a 0 in for x. What is 1/2 of 0? 0. 0 plus 1? 0 is less than or equal to 1. Yes. So, am I shading above or below my line? Below, because that's where 0, 0 is. If you need to like highlight it or something, figure out where your origin is, it's easy for it to get lost in all that's going on. Okay? So we have to keep track of our origin. We are going to shade down here. Alright, and we only want our final answer to include the intersection. So where is that happening? Here? Yes. What about right here?
Yep.
No. This little triangle is getting left out. Why?
That's not allowed.
It's not shaded for which line?
I'll shade it for that one.
This line, right? This line cuts it off. So our final answer does not include this little section up here.
I think we're just
or this little section over here. Right? So it might be easier on this one to just darken up what is included. So we start at that solid line. We go follow down this solid line, and it's all the stuff down here. It's a large portion of our graph. Questions about how we determine which parts are or are not included? Nothing? No questions. So this is not part of it. Okay. All right. Before I turn you loose on this problem, I want to make sure we all know how to get this top equation into slope-intercept form. What do I need to do? Divide by -2. Now don't tune me out just yet. If we divide each of these by -2, we end up with y over, on the other side we've got -2x minus 1. But what special thing happens when you divide an inequality by a negative? Flip the inequality symbol around. Flip it around. If you don't do that, your shading won't come out right, your problem won't come out right.
So it's a positive, they're both positives?
Alright, so we had somebody come to the board and graph this, so we'll talk through what they did. So if we are graphing this bottom equation, we've got -1. Alright, so we start at -1 on the y-axis, and we used our slope, -2, to get more points. Our line is dashed because it is a greater than symbol without the equal to bar. We tested the point 0, 0. That showed us that 0 is greater than -2 times 0 minus 1. So we end up with 0 greater than 0 minus 1. 0 is greater than -1. That is a true statement, so we graph or shade on the side of the line where 0, 0 is. So we are going to just lightly shade in this side of our line before we graph our other line. Alright, we had another classmate come up to help us graph. Another student came and graphed our other line. Y is greater than x plus 2. That means we start at 2 on the y-axis, use our slope 1 over 1 to get more points. Our line is also dashed because it is just greater than, it doesn't have the equal to bar. And when we test the point 0, 0, we end up with 0 is greater than 2. That is a false statement, so we graph on the other side of the line. So instead of graphing down here, we graph up here. And when we do that, we should be able to see that those graphs intersect in this triangular portion at the top in the middle. So that would be the area we would either want to shade in more darkly, or your other option is always to erase the shading that we do not want as part of our solution set. Personally, before I start these, I like to have them in slope-intercept form. If you want to graph this bottom one from standard form, you can. It's just not my favorite way of doing things. So if I'm going to change the bottom one to be in slope-intercept form, what do I need to do? Charles? Add the 6x. Okay. So that gives me 2y is greater than 6x plus 4. Is the y alone yet? No, so I have to divide everything by 2. When I divide everything by 2, we get that y is greater than 3x plus 2. Questions so far? Okay, so I'm going to replace this equation here with with y is greater than 3x plus 2. I'm going to erase all this work so that I have more space for the rest of the problem. All right, somebody new, help me out with the graph.
That 1 on the y-axis.
1 on the y-axis.
Slope, it's up 3 over 1.
Up 3 over 1. Wonderful. And we keep on doing that. We get more and more points. We can also go down 3, left 1 to get more points. And Logan, will this line be solid or dashed? Solid line. That's pretty good for a first try. All right, what point do we want to test? Anybody? All right, we can still test 0, 0. It is just barely below that line, but we can still test it. It's not on the line. So if I test 0, 0, I have 0 is less than or equal to 3 times 0 plus 1. 3 times 0 plus 1. Is 0 less than or equal to 1? Is 0 less than 1? Class?
Yes.
More than one student in this class?
Yes.
Yes, 0 is less than 1. So that means I'm going to shade on that side of the line. Shading, 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 shading. Okay, we go to graph the other one. Who's going to help me with that one? Sadia.
Okay, go to 2 on the y-axis, positive 2.
Okay, up to 2.
And then you go up 3 to the right one, or down 3 to the left one.
Up 3 to the right one. Up 3 to the right one. Or down 3 to the left one. Now these lines are awfully close together. All right. Oh, I'm not going to be able to get a great line in here. Is this line going to be solid or dashed? This one would be dashed. So I dash in a line here. Those lines are awfully close together. What do we know about those lines? They're parallel. How do we know that even if my graph doesn't look so great? Same slope. Okay, so those lines are parallel. They should be like right next to each other. What point do we want to test? 0 is greater than 3 times 0 plus 2. What's 3 times 0?
0.
Is 0 greater than 0 plus 2? No. So am I going to shade above or below? Above. What do we notice? They don't overlap. There is a skinny space in between them, and they most certainly never actually touch each other. So what do we think our answer is? No solution. Questions about that? If you graph them both and they don't overlap, your answer is no solution. On this one, I should see that you shaded both sides of those lines. All right, we've got one more example. We are at least going to get it started. We should be able to get it done. On the bottom one, to put it in the correct form, what do I need to do? That one's the quicker one. Add 2x. So we get 2x plus 1. The other one's a little bit more involved. What's the first thing I'd have to do? Add the x over. So that would be negative y is less than or equal to x plus 2. But then what do I have to do? Divide by negative, which means the sign in the middle flips. So we get y is greater than or equal to negative x minus 2. All the signs flip. And that is my new system. All right, graphing the top one, I start at -2 on the y-axis. I go down one, right one. Is my line going to be solid or dashed? Solid line through those. It's going to be close enough for now. Where do we want to test a point?
0, 0.
So we plug in 0 here. 0 is greater than 0 minus 2. What's 0 minus 2?
-2.
Is 0 greater than -2?
Yes.
Yes. Shade above where 0, 0 is. All right, the other one, we start at a +1 on the y-axis. We go up to right 1, up to right 1. Do I want a solid or dashed line?
Solid.
Right?
Yeah.
Dashed, why? It's okay. We want a dashed line because there's no equal to bar on it. What point do we want to test? We can test 0, 0 again. We plug in a 0 here. We've got 0 is greater than 0 plus 1. What's 0 plus 1? Is 0 greater than 1? No. So we do not shade where 0, 0 is. We shade the other side. That would be the top side of it. So where do we see them overlap?
On the top portion.
That
To the left.
top left triangle. That is our solution space. All right, the last slide shows us our homework. Page 132, numbers 1 through 15, odds.